Number 4. Wait. What? Y'all only went through what? 12. What are you talking about? Y'all only went through 12.
What?
Here we go. Thank you, Brian. Thank you. I'm just going to work this problem. I'm going to differentiate both sides with respect to x, which means that every time I take the derivative of y, I follow with a dy dx. That's the only thing that means. Everything else, exactly the same. All right, so here we go. 2x equals, I've got a quotient, so I'm going to use quotient rule. Derivative of the top, which would be 1 minus, what's the derivative of y? Dy dx. 1 dy dx. So minus dy dx times the derivative of the bottom, 1 plus dy dx, minus the top, no, bruh. I'm being nosy. I'm steady trying to hear what's going on next door to go. You're like, all right, derivative of the first times the derivative of the top times the bottom minus the top. That's what I get for being nosy. Times derivative of the bottom. 1 plus dy dx. Okay, now I'm ready. Over the bottom squared. Like, I hope that's not coming from 2 doors down where there's supposed to be a sub coming. Miss Phelps has planning first block, so she's right next door. It's a letter opener and a staple remover. I think it's a bird. These birds like nosedive through around here, and I keep it catches the corner of my eyes a lot. Yeah. All right, so remember, I have to get dy dx by itself. So my goal here is to solve for dy dx. Okay, so the first thing I'm going to do as I solve for dy dx, and you may have gone about this a completely different way, but I'm going to multiply both sides by that just to get rid of the fraction. Because there's no dy dx in there, I'm going to leave all the dy dx's on the right side and move everything else to the left. So that's the first thing I'm going to do. I'm not going to FOIL that out. I'm not going to multiply that out because that has no bearing on me getting dy dx by itself. Yes? So I'm just literally going to say now I have 2x times x plus y squared equals 1 minus dy dx times x plus y. Now, the other side, this is a whole different story now, because in order to isolate dy dx, I do have to multiply these out first. Right? Because there's no other way to get them by themselves, yes? Because there's one here. Okay. So here we go. X plus y minus x times dy dx plus y times dy dx minus, I'm going to go ahead and put this in parentheses so that I don't mess up my signs here, x plus x dy dx minus y dy dx. Wait, I forgot the minus y. I am going to do this so I can see if I have any like terms, and I do, because I'm going to combine it with some of these in here. I've got a negative x dy dx and another negative x dy dx, which gives me what? Negative 2x dy dx. Do the same thing with the y's. I've got a y dy dx and another y dy dx. Two y's, the x's cancel. Did y'all get that? Is that what y'all got?
I did not even put.
What'd you do?
Oh, I got it wrong.
Oh, you did it wrong.
Yeah.
Okay, I'm not done yet. Yeah, we're fixing to go crazy too. Minus 2y. So now I have 2x times x plus y squared minus 2y. Factor that, that's exactly right. Factor that dy dx out from the right side. So now I have dy dx times negative 2x plus 2y. And now I'm going to divide by the negative 2x plus 2y. So I get 2x times x plus y squared minus 2y over negative 2x plus 2y. I'm going to leave it right there. I'm assuming if you probably multiplied out the top, something may or may not cancel out to simplify.
Probably get a 2 out of there.
Okay, well, let's see what happens. You could get a 2 out. Nice job, Robert. So, yes and no. And the reason being, if you're on a multiple choice part, you have to know that you have to be able to rework it. But if you're in an FRQ type thing, which is where you probably see this problem, you could leave it there. If I multiplied it out, I'd have x squared plus 2xy plus y squared minus y. We'll talk about, some of them are so straightforward, some of them take longer. We will talk about time management and how you go through to best work your time. You'll be okay. I don't know that time's ever been an issue for me because we drill it so much. You'll be so used to it. Now, if you walked in and that was the very first time you'd ever done a full-on 3-hour calculus exam like that, or 4 hours, then yeah, you never finish. But you'll be practiced up and ready to go. I could keep going on this. I'm gonna stop though because really there's no. I would be okay there. Did it say write it with only x's? Because technically you can go back, you can solve the original equation for y and go back and plug that in. Yeah, I don't know what they did. But technique-wise, do y'all understand how we got dy dx by itself? Okay. Give me another one. Look at that beautiful problem. No, it does. Nothing else? Like 5. Derivative of the left is 1. Derivative of the right would be secant squared y right? Because for the tangent, we do the power, and then we do the trig, and then we do inside. Now what's the derivative of the inside? If I solve that for dy dx, so I'm going to divide by, I feel like we did this Friday. I did chain rule. Normally that would be an x, and so the derivative of x is just 1, but because this has got a y in it, the derivative of y is dy dx. That's why it's a little bit. This is not completely simplified though, because think about this. If secant is 1 over cosine, then 1 over secant is cosine. So this is really just cosine squared y. You would need to recognize that. That's one of those things to recognize again. Yeah. What else? Recognize that it would simplify to that. Yeah. What else? Give me one. 11. Okay. X minus 1 squared plus y minus 1 squared equals 13. Let's do the derivative. So I'm going to do 2 times x minus 1, and then I'm going to chain it, but the chain here, the derivative of x minus 1 is just 1, right? But on the second piece, what's the derivative of y minus 1? dy dx. Derivative of 13 is 0. So it says to find the slope of the curve at the indicated point. The indicated point is 3, 4. So I am just going to plug in 3 for x and 4 for y. Go about my merry way. You can solve for dy dx here, or you can solve for dy dx after you plug in. I find it a little easier after I plug in, but whatever you want to do. 3 minus 1 plus 2 times 4 minus 1 dy dx equals 0. This is going to be 2 times 2, which is 4. This is going to be 2 times 3, which is 6. dy dx. Now all I have to do is subtract 4 and divide by 6, which is going to be negative 2/3. Yes, no, maybe, sir? Better than the last day of chain rule, at least? Good. We're going to write some tangent lines today, then. Every single time. Almost every single time. It never goes away. At least not the first half. Before we do that, Ooh. Tell me everywhere that dy dx is defined here. Mark, set, go. Where is dy dx? This is more implicit differentiation. All the rustling of paper. See if you can figure it out. Where is dy dx defined? It feels hot. Did you start by finding dy dx? If you need to know where it's defined, then I first need to find dy dx, right? I can't say where it's defined if I don't know what it is. Anyone have trouble finding dy dx there? So now the question is there any place where this function is not defined? What causes me not to be defined? The bottom going to 0. So my question to you is, when does this happen? It's nowhere. Why is it nowhere? That's exactly right. Cosine will always, no matter what here, it's always going to fluctuate between -1 and 1. So because of that, this will never be equal to 0, or negative cosine y will never be equal to -2, because cosine y will never be equal to 2, because it can't. It never goes above 1. Does that make sense? So the question was, where is dy dx defined? Everywhere. It's always defined. There's no place where it's not defined. It always has a slope. That's right. Does that make sense? So I'm looking at where the bottom would go to 0. Y'all ready for a little bit harder? Defined everywhere. So where is it defined from negative infinity to infinity? There's no place where the bottom would equal 0. It can't possibly equal 0. Now, if this had been 2x over 2 minus y, well then, could 2 minus y equal 0? Sure it could. It could when y is 2, right? So for this one, where is it defined? Everywhere except where y is 2. Let's do a tangent line. Let's do a tan and a normal. I'm going to give you a second to try this one, and then we'll work it together. To the ellipse, it's an ellipse. What an ellipse look like when you graph it. You were thinking the moon. An ellipse is like an oval. It's like a smush circle. X squared minus xy plus y squared equals 7 at the point -1, 2. Mark, set, go. Tangent line and normal line. We can come back together. going to do derivative here. I got to do product rule, and I'm going to put it in parentheses to make sure I don't mess my sign up. Derivative of the first times the second plus the first times derivative of the second. dy dx. Did you forget to distribute the negative through? Do what? This? Because it's a product, so I had to do product rule. Derivative of the first times the second plus the first times derivative of the second. Why do you hate that? I thought you liked implicit differentiation. 2x minus y minus x dy dx plus 2y dy dx. Don't forget to take the derivative of that 7. I think that's what you were talking about, Madison, there on the end. And so now I'm ready to get all my dy dx's together and everything else on the same side. So I'll move these two over here. I've got 2y, I'm just going to switch these orders because I don't like starting with a negative sign, but it doesn't matter. Y minus 2x. Now I need to factor that dy dx out. I enjoy these. Y'all don't like these? It's always more fun when you know what you're doing. Dy dx equals y minus 2x over 2y minus x. That is the slope. Slope anywhere on that ellipse can be found by plugging into that equation. So then they gave me a point. They said at the point negative 1, 2. So I'm going to plug in that equation. So 2 minus 2 times negative 1 over 2 times 2 minus negative 1 should be 2 plus 2, so 4 over 5. This is the slope, that's right. This is the tangent, so then normal would be negative 5/4, right? And I've got my point. Opposite reciprocal. So point slope, I'm going to do the tan line, slope times x minus x1, and then the normal line, minus 2, just changes that slope in front. What you think? You got it? Do we need to do another one? Yeah. Let's do, let's do 23 from the homework. Okay, so I got to come back to that. Remind me I have those practices for us to do. 2xy plus pi sine y. Robert, this one's for you. 2 pi at the point 1 pi over 2. Give me the normal line and the tangent line. Mark that down. It's not a variable in that sense. It's a constant. I'm dy dx here. I'm going to do product rule. Derivative of the first times the second plus the first times derivative of the second. Or if you pulled a 2 out altogether, that's fine too. All right, so I did it as this times this. So the derivative of 2x is 2 times the second plus the first times derivative of the second.
Because I did 2 times x.
But then you've got a 3 times product rule if you do it like that. What I would do, okay, try this.
But can you see what I didn't do before?
Yeah, if you didn't get what I got, it's not mine.
All right, let me see. Look, I did that. Oh, I do that.
Here's a constant out front. So do this. Try pulling it out. Do 2xy and do the derivative of this. So 2 times, and now do the derivative of xy. Derivative of the first times the second plus the first times derivative of the second. Again, with the pi, I can pull that out front because it's a constant. And now the derivative of sine is cosine. But what's the derivative of y? dy dx. And what's the derivative of 2 pi? 0. But pi is a constant, remember? So could you get an actual numerical value here without plugging anything in? Yes. It's 6 point whatever, right? Pi is 3.1415, right? What's the derivative of a constant? What were you saying, Joyce? Everybody okay on this stuff? The pi keeps throwing us. The variables that are not actually variables but are constants seem to throw us more than anything else. Treat pi just like it was a coefficient, just like it was a number, just like it was anything else. All right, so let's clean it up and solve for dy dx. I have 2y plus 2x dy dx plus pi. This dy dx can go anywhere. Cosine y. That's right. So on the left side, I have 2x dy dx plus pi dy dx cosine y equals negative 2y. Factor out that dy dx. 2x plus pi cosine y and divide. What'd I do?
Wait. What is the?
What's the derivative of 2 pi?
Oh, I forgot. What is it?
Yeah. Here. Yeah. Correct. Yeah. Come out when I took the derivative. Yeah, just like a coefficient out front. Are you okay? Y'all look pained. Y'all always do this to me. All right. So now I'm going to plug this point in so that I find the actual derivative at this particular point. What point did I tell you? -1. Oh, no, just kidding. I'm looking at the wrong one. So there's 1 pi over 2. All right, so I'm going to plug in, yes? All right, so -2 pi over 2, 2, 1, pi cosine of pi over 2. Let's see. Yeah. That's what I got for the slope. Cosine of pi. Oh, it is 0. It is 0. I lied. I didn't finish. Now write the equation. Normal line, tan line. Both of them. Or tan line, normal line. Whichever order you want to go in. Only thing that changes on that normal is we flip the switch. There we go. Remember that point was 1. I think we'll save second derivative for tomorrow. Because then you actually. I'll show you a couple of these. Where's they go? I know you'll send me an item. Did I? I wrote all those, and now we're saving second derivative for tomorrow. I don't want to throw too much because I feel like I'm gonna let you work on your homework and all right, let's do 17 through 22 because we did 23 together. And then these are rational exponents. Pick up all the second derivatives tomorrow. Y'all remind me I said second derivatives tomorrow.